Hello everyone. In this video we are going to start with a network of PMUs and PDCs. We know that in the fields we are having the PMUs. Okay, PMU is a device we have seen to estimate the magnitude and the phase angle of the voltage and the current. It sends data to the PDCs and the PDCs send data to super PDCs. After that, I already told that we need to use our Fourier series and Fourier transforms for further process. So when we see the Fourier transform, we get this equation where A0 is this, An is this and Bn is this, where this term is our even part and this term is our odd part. In the similar function, when we try to see that our Fourier transform, it represents signal as a sum of infinite number of sinusoid. We'll get something equation like this, where x of t is a band limited if Fourier transform is 0. Band limited signal is infinite duration in time, right? Then comes our DFT. It's used when the limited number of samples are needed over a window. Then this equation is used. Use DFT to find the phasor value. To find the phasor as well as means voltage as well as angle, we use our DFTs, Fourier transform, Fourier series and so on. Now when we try to see the phasor update, there are two types of technique in which phasor is updated. That is non-recursive technique and recursive technique. First of all, non-recursive, fresh window phasor sample every time. So this technique is stable. Recursive technique, phasor stationary and not rotate, numerically unstable and computational efficiency is more. So basically when we talk about efficiency, recursive technique efficiency is more and non-recursive technique efficiency is less. Fresh window phasors in this, and basically it's stable and this recursive technique is unstable. That is what we need to know in this part. Then comes our PMUs. So basically this part will be covered under PMUs, right? So PMU, when we talk about, there is PMU compliance requirement, that is IEEE C37.118. It gives me dynamic performance for frequency and rate of change of frequency and synchrophasor data communication. So when we talk about dynamic compliance, here different tests are being used, like frequency and amplitude modulation test, designed to reflect small signal oscillations, vary modulation frequency in steps of 0.2 Hz or smaller. Frequency ramp test is a linear ramp, step change in magnitude and phase frequency for simulating transmit scenarios. Then comes our latency. There are two types of PMUs. First is our P class and second is our M class. P class will have latency 2 by Fs and M class will have 5 by Fs. PMU data communication is 112 bytes. PMU communication with PDCs, bandwidth required is 10, 25 and 50 Hz. If I talk about 10, it will give me 6720, 16800, 33600. Right. And then comes our application of PMU. Okay, before we begin to our application of PMU, I will tell about something about PMU data communication. When I talk about how the data communication happen in PMU, we will see that IEEE standard C37.118.2 defines following types of messages for PMU communication. Okay, so when we talk about PMUs, some different types of data communication messages are being used. Like number one is our data. Data messages correspond to measurements made by PMU. Okay, so this is my PMU. It will make some measurements that will come under data. Then comes configuration. Configuration message contain the information about calibration factor and metadata. Third comes our metadata. So it is required to properly decode the data message, which are normally in machine readable format. Fine. Then comes our packet. Packet contains various layers of network protocols. We know that there are network protocols available. So packet will contain various layers of network protocol necessary for efficient and secure message exchange over the network. Then fifth comes our command. Command messages control the operation of synchrophasor measurement device and transmission of the data configuration. The total size of IEEE C37.118 data word is around 112 bytes, as I already told here. Then comes our C37.118 data frames. We know that when we talk about different data frames, in this, if I divide this, if I talk about different data frames, we will have here is Ethernet trailer, then comes our payload, here payload, UDP headers, over that IP layer will also come, and then Ethernet header will come. Then in payload we will have some more boxes here, some more layers will be there. Here sync will be there, frame size will be there, ID code would be there, data would be there, and in data there are further division here. Here it contain digital, analog, frequency, phasor, stat, synchronized. So these are all the data frames of C37.118. Then comes our Pmu communication with PDCs. Now we know that Pmu communicates with the PDC. Now we will see how they communicate with the PDC. So what happened here is, this is my Pmu and here is my PDC. So what happened here is, PDC sends the command frame, it sends some configuration file to the Pmu, config file, and Pmu sends the configuration frame. Then it sends the command frame, turn on transmission of the data frame. Then it sends the data to the PDCs. In this fashion it will come, and after that, after the completion, it will say to turn off the transmission data frame. Then comes our Pmu applications. In Pmu applications, one of the most important application is protection against the fault. That is one of the major advantage of the application of the PMUs. So basically, when we talk about PMUs, it gives me phase information, magnitude as well as angle. It helps in stability monitoring. Then comes our calibration of instrument transformer, special protection system monitoring, model validation, fault identification, energy market operation, wide area control, and controlling tuning, PSS. That is the thing that is a Pmu application. Next comes our smart meters. So when we talk about metering, so first installed meter was in 1851, that was our gas meter. After that, as a technology got increased, we got our first meter, smart meters, with a two-way communication in 2009. We know that the conventional energy meters we were using, and it was having so many problems, but now we are having the smart meters that gives a real-time reading of transmission. It gives me features for remote connect, disconnect, and support various types of communication protocols. Right. So now we will see about something about the AMIs. So AMI, when we talk about, is something called as advanced metering infrastructure. It includes smart meter, communication network, meter data acquisition system, meter data management system. It is a two-way communication between the customer and the utility. When we study first meter data acquisition system, it's a real-time data acquisition from the data concentrated unit like a DCU. So what we do is, we extract data from the DCU that is used for real-time data acquisition. It's user management module, meter management module, data servers, and reporting module. Then comes our meter data acquisition system. After that, it comes meter data management system. Database with analytical tools, use data for CIS, OMS, GIS. Service, remote connect, disconnect, feature it provide, and demand response management. Provides API with meter data management system and other software applications.